Okay, so we've got a second example to do dynamics and inclined planes. So we've got a box of mass 2 kilograms being pushed up a rough plane by a horizontal force of magnitude 25 newtons. The plane is inclined to the horizontal at an angle of 10 degrees. Given that the coefficient of friction between the box and the plane is 0.3, find the acceleration of the box. Okay, so start by getting a nice diagram so we can see what's going on. So this will be our plane. We've got an angle of 10 degrees to the horizontal. This is going to be our box. It's got a mass of 2 kilograms. It's been pushed up the plane, so we're going to be accelerating upwards here. And then we want to label the forces. So we've got the force that's pushing it, which is 25 newtons. We're going to get a reaction force from the plane. We've got the weight of the particle, which is going to be 2g newtons, mass times by g. And then we've got friction. Well, friction is going to be opposing the motion, so it's going to be going in this direction instead. Okay, so we've got various unknowns on here. So we've got the acceleration, we've got r, we've got f. So let's dive right in. So the first thing that we could do is work out what r is. So that's going to involve resolving perpendicular to the plane. So to do that, we want to split these two forces into their components that are parallel and perpendicular to the plane. So if we do a little triangle here and here, this angle will be 10 degrees. This angle will also be 10 degrees. So this is 2g cos 10. This is 2g sine 10. And then here we're going to have 25 sine 10. And this bit's going to be 25 cos 10. So if I resolve perpendicular to the plane, I've got going sort of upwards from the plane r. The 25 sine 10 is pushing down into the plane. So it's going to be take 25 sine 10. And then we've also got 2g cos 10 pushing into the plane. So take 2g cos 10. Because it's not accelerating perpendicular to the plane, it's accelerating parallel to the plane, that's actually equal to 0. And so r would be equal to 25 sine 10 plus 2g cos 10. And we can just calculate what that is. Okay, and then that comes to 23.6434364. Well, because we know what r is, we can also work out what f is. Because the box is actually in motion, which means that f equals mu r. So in motion, so f equals mu r. Mu was 0.3 as given in the question. R is what we just calculated. So we need to do 0.3 times by r, which is 7.09303092. And then what we want to do is resolve parallel to the plane now, and then we'll be able to work out what the acceleration is from there. So resolving parallel to the plane, so that way, I've got 25 cos 10s pushing up. The friction is going against it. That's going to hold us back. We've also got the 2g sine 10, which would be pulling us down the plane as well. So take 2g sine 10, and that's equal to the mass times the acceleration, rather than equal to 0, because it is actually accelerating up. Well, we worked out what f was a moment ago, so we're going to be able to substitute that in, and then from there we're able to solve to find a. Okay, so we get 14.12365.862 is equal to 2a. So all I need to do is obviously divide that by 2 to work out what the acceleration is. So that's 7.06 meters per second squared. Just notice I've kept as much in my calculator display as I could when I was working this out until I got to the answer, which I then rendered, just so I don't lose accuracy earlier on. Anyway, that's it.